Hi, I'm Prajesh Prasad from the Interdisciplinary Program in Educational Technology at IIT Bombay, India, and I will be presenting the paper VeriSIM, a learning environment for comprehending class and sequence diagrams using the pedagogy called design tracing. Let us start with the example of a graduating student entering the workplace. It is Ajay's first month on the job. He is introduced to his team, and instead of working on a new project, he has to work on an existing project and add two new software features to the existing design. This scenario is not uncommon for novice software developers. When they graduate and enter the software industry, they spend their first several months resolving bugs and writing additional requirements. These activities require them to explicitly comprehend software designs. However, we see that developers they try to avoid comprehension because they find it difficult to comprehend large programs. We also see that there is a lack of training in software design comprehension in both software design courses as well as introductory programming courses. When we look at how experts comprehend software designs, we see that they create detailed mental models, perform mental simulations on these models, and simulate various scenarios in the design. They also switch between different diagrams in order to build an integrated model of the design. So to summarize, experts create an integrated model of the design and simulate scenarios in this design. We have come up with a pedagogy called design tracing, which helps learners comprehend class and sequence diagrams. In design tracing, learners create a model of a scenario which is similar to a state diagram. We believe that tracing scenarios in the design leads to better comprehension of class and sequence diagrams. We have incorporated the design tracing pedagogy into VeriSIM, which is a learning environment for comprehending class and sequence diagrams. In VeriSIM, learners go through three stages. In the first stage, which is the problem understanding stage, the learners go through the requirements, the design diagrams, and scenarios in an automated door locking system. In the design tracing stage, there are 4 challenges. In these challenges, learners progressively trace different scenarios of the automated door locking system. And finally, they reflect on what they have learned in VeriSIM. The first challenge in the design tracing stage is explore the model. In this challenge, learners are presented with the class diagram and the sequence diagrams of the automated door locking system. They are also presented with the scenario and the state diagram which models this scenario. In the state diagram, the state corresponds to the variables in the class diagram and their values, and the transitions refer to the messages in the sequence diagram. The learners can click on the Run button in order to visualize the execution of the scenario. We see that when the learner clicks the Run button, the appropriate parts of the scenario and the state diagram get highlighted. The appropriate parts in the sequence diagram and changes in the class diagram are also seen by the learners. This enables them to comprehend the design diagrams and also understand the relationship between the sequence diagrams and the class diagrams. Now, the second challenge in the design tracing stage is correct the model. In this challenge, learners are presented with an incorrect model and they have to correct the model in order to proceed further. We see that when the learner clicks on the Run button, the incorrect state in the state diagram is highlighted in red. The learners have to click on the Edit button and edit the states and the values of the variables which correctly model the scenario. They do this until they correctly model the entire scenario. The third challenge in the design tracing stage is complete the model. In this challenge, learners are presented with an incomplete model. The events are provided, but the states, the values of the variables in the states are missing. Learners click on the edit button, add the appropriate relevant variables from the class diagram and their values. The learners continue to edit the states till they correctly model the entire scenario. We conducted a study in order to understand the effect of VeriSIM on students' comprehension of design diagrams. We tried to answer two RQs. Firstly, does VeriSIM improve the learner's ability to trace a given scenario? And what are student perceptions of the usefulness of design tracing? Study was conducted with 86 final year computing undergraduates who were familiar with class and sequence diagrams. Firstly, learners filled a pre-registration form and then they solved a pre-test. The pre-test contained the design of an ATM system and the question given to them was to execute a given scenario. They then interacted with VeriSIM and they solved a post-test after that. In the post-test, the design of a library system was provided and the question was to execute a given scenario. A focus group was conducted in the end in order to understand learners' perceptions of the workshop and VeriSIM. The data analysis used to answer RQ1 was a difference in the post-test and the pre-test questions based on a rubric, which we'll explain in the next slide, and a thematic analysis of the feedback form and focus group interviews was done to understand student perceptions. This is the rubric which we have used to evaluate student responses in the pre-test and the post-test. As you can see, the rubric has three criteria. In order to trace a given scenario, learners have to identify relevant data variables and relevant events and simulate the state change. We see that there are three levels in this rubric. The missing one indicating that students miss all relevant variables, events and states, and target referring to they being able to identify all relevant variables, events and states while tracing a scenario. Moving on to the results, we see that there is an increase in the number of students from the pre-test to the post-test who have come to the target level in the data, the event as well as the state criteria. On doing a paired t-test, we see that there is a statistically significant improvement in students' ability to trace scenarios. We also find that students perceive that the design tracing strategy is useful. It helps them understand the logical flow of the design, the variables and their change in values, and an integrated understanding of different design diagrams. It also helps them think of different scenarios in the design and identify missing features and errors in the design. To conclude, we see that students find the design tracing strategy useful, and we also see that there is an improvement in their ability to trace scenarios. As part of our future work, we wish to add more examples and design diagram scenarios. Design tracing can be used as a precursor strategy to comprehend simple as well as complex design diagrams. Adding more examples and scenarios will enable learners to apply the design tracing strategy to different design examples. Thank you.